Hello everyone, welcome all to Physics with Astronautics. So in this video, we will discuss about some 2023 CPET physics paper with solution. So let's begin. And here is our first question of the session that says, if difference between nth and n plus 1th Bohr radius of hydrogen atom is equal to its n minus 1th Bohr's radius, then the value of n is. And here the options are 4, 3, 1 and 2. So let's come to the solution, and we know that the Bohr radius of hydrogen atom is proportional to n square. So here, according to the question, it has been saying that the nth and n plus 1th Bohr radius of hydrogen atom is, the difference between the nth and n plus 1th Bohr radius of hydrogen atom is n minus 1th Bohr radius. So here we can take it as n plus 1 whole square minus n square is equal to n minus 1 whole square, because we know that the radius is proportional to n square. And from here we can find that the n value will be equal to 0 or 4, where 0 is not possible. So here the final result is 4. So here the option A, that is the answer is 4. Then if mass number of nucleus is A, then the Coulomb energy term EC in Weizsäcker's mass formula is related to AH. And here the options are proportional to 1 by A, proportional to 1 by A cube, A to the power 2 by 3, and proportional to A, and the last option says is proportional to 1 by A to the power 1 by 3. So we know that the Coulomb energy is proportional to 1 by r. Again we know that the radius is proportional to a to the power 1 by 3, where a is the mass number. So from here we can get that EC will be proportional to 1 by a to the power 1 by 3. And here option D, that is EC is proportional to 1 by a to the power 1 by 3 is the right answer. Then the half-life of radioactive decay is x times its mean value, then x is. And the options are 0.3010, 0.6930, 0.6020, and option D says 1 by 0.6930. We know that the half-life is equal to ln 2 by lambda, where lambda is the decay constant and the mean value is 1 by lambda. So from here we can get that T half will be equal to ln 2 T mean, and the ln 2 value is equal to 0.693. So T half will be equal to 0.693 T mean. So here the X will be coming out to be 0.693, that is option B. And here is the fourth question. For wave function psi of x is equal to n e to the power minus x square by 2, and here the normalization constant n is, we have to find out the value of n here, and the options are 1 by root pi, 1 by pi whole to the power 2 by 3, 1 by pi whole to the power 1 by 4, and option D is root pi. So we know that how we find the probability, that is the integration over minus infinity to infinity psi star psi dx is equal to 1. So by putting the value here we can get it as, by integration we can get it as the n value will be equal to root 1 by pi whole to the power 1 by 4. So here the option C is the correct one. Then the expectation value of Px for the wave function psi of x is equal to root over of 1 by 2 by L sine pi x by L for x from 0 to L, and here psi x is equal to 0 for x greater than L each, and the options are 0, 1 by L, L and L square. So basically we have to find out the average value of Px here. Let's jump to the solution. So basically we have to find out here the expectation value of Px, or the average value of Px. So we know the formula for it as integration over 0 to L psi star minus I h cot del by del x psi dx whole divided by integration over uh, 0 to L psi star psi dx. And we know that the integration over 0 to L psi star psi dx will be 1. So here we are only finding the value of 0 to L psi star minus I h cot del by del x psi dx. So by putting the value of psi here or psi star, that is because this is the real function, so the psi and psi star value will have the same equation. And by integrating it, we can find the final result h 0. So the expectation value of px will be 0. Then if the 0 point energy of one-dimensional harmonic oscillator is 5.25 into 10 to the power minus 27 joule, then the energy of second excited state is. And here the options you can see. So let's jump to the solution directly. And we know that the general form of the energy of 1D harmonic oscillator is given by E is equal to n plus half h cross omega. And here it has been given that the 0 point energy of one-dimensional harmonic oscillator is 5.25 into 10 to the power minus 27 joule. So by putting the value of n equal to 0 here, we can find that the 0 point energy E, that is equal to half h cross omega, will be equal to 5.25 into 10 to the power minus 27 joule. And the question asking is the energy of second excited state. So the first excited state will be where n equal to 1, and the second excited state will be where n equal to 2. So by putting the value of n equal to 2 here, we can find it as 5 by 2 h cross omega. Again, we know the value of half h cross omega. So by multiplying it with 5, we can find the value of second excited state, that is coming out to be 5 into 5.25 into 10 to the power minus 27 joule is equal to 26.25 into 10 to the power minus 27 joule. So here the option D is the correct answer, that is 26.25 into 10 to the power minus 27 joule. Then change in kinetic energy due to Larmor precession in case of an electron orbiting in magnetic field P each. And the options are L BE by 2m, L BE by m, BE by m, and L B square E by m. And here it has been given that L is the original angular momentum. And here we can see the solution, that is mb square by r is equal to qbb, that is the force. And we are equating it. Again, it has been given that in case of an electron, so we know the charge of electron, that is q is equal to E, and here in place of q you can take it h E. So mb square by r will be equal to evb. Again, we know that the angular momentum L is equal to mvr. So from here we can get the value of r, that is the radius, will be equal to L by mv. So the change in kinetic energy will be equal to half mv square. So from here we can get that half mv square will be equal to evb r by 2. So by putting the value of r here, we can find the final result h L B E by 2m. So here the correct option is option A, that is L B E by 2m. Then choose the incorrect statement. The options are change of entropy in reversible cyclic process is 0. This is the right statement. Change in entropy is path independent in any thermodynamics change of a system. So because this is a state function, so entropy is path independent. This is also correct option. In irreversible process, that total entropy of system and its surrounding does not change. This is the incorrect one. So this is the right answer here, that is it has been saying that choose the incorrect statement. And option D says the entropy can never decrease in any process. That we know that entropy always increases. And again we know that the entropy is the measurement of D is otherness. So here the option C, that is the incorrect statement, is the right answer here. Then for 1 mole of van der Waals gas, that is del U by del V at constant temperature is equal to, options are A by V, A by V square, AV and A by V cube, where A is the van der Waals constant and V is the volume. Then we know that del U by del V at constant temperature is equal to T into del P by del T at constant volume minus P. So the van der Waals equation for 1 mole of gas will be equal to P plus A by V square, V by B, V minus B is equal to RT. Because we know the van der Waals gas equation H, P plus AN square by V square into B by NB is equal to nRT. So by putting the value of n here, we can find this equation. And from here, we can get the value of P, H, P is equal to RT by V minus B minus A by V square. And by doing the differential with respect to T here, del P by del T at constant volume will be equal to R by V minus B. So by putting this equation in the above equation, that is in this equation, we can find it as del U by del B at constant temperature will be equal to T into del P by del T at constant volume, that is equal to R by V minus B. So here it will be TR by V minus B minus P, and P is equal to, we know that RT by V minus B minus A by V square. So here the final result will be coming out to be A by V square, that is the option B. Then most probable speed cmp of gas molecules in absolute temperature T is, and here the option A says it proportional to root T, proportional to 1 by T, proportional to 1 by root T, and proportional to T. So we all know that the speed of, the most probable speed is equal to 2 to the power of 2 RT by M. Here R is constant and M is the molecular mass. So from here we can get that CMP is proportional to 2 to the power of T, that is the square root of temperature. So here the option A is the right answer. I hope you all enjoyed this session. So for more videos, please do like, share and subscribe. Thank you.